We have an age variable and we have a blood pressure variable, and we're wondering if they are statistically significantly correlated. So the first thing you want to do is make a scatter plot, but that's not the focus of this video. And if I look at that scatter plot, man, I can't tell. It looks pretty horizontal. But I don't want to go by the naked eye. I want to go by the hard numbers. I want to make a hypothesis test. I want to be formal about my any sort of conclusion I try to draw. The line looks horizontal, and that means it doesn't look like one variable is causing an increase in the other. But to test, to be sure, oops, this is from another. Um, there are you have to. I think you have to type in the formula yourself into Excel, into Google Sheets, and that's pretty tedious. You got to make sure you get the parentheses right. You could do it by hand, but the whole point of using technology is that we want to save ourselves time. In reality, what's going to happen if you ever use statistics is there's like probably 5 or 6 dominant statistical packages out there, and they all have pretty straightforward functions with how to do this. We really just want students to know how to get the p-value, how to interpret the p-value, because getting the p-value, that's just a matter of, following the right tutorial online for whatever function you're using. So to get the p-value for that hypothesis test, we're going to go to regression significance calculator. There's a bunch that pop up. This one I wasn't sure what some of the symbols they were referring to. They said beta, but they didn't. Beta could be the intercept or the slope. So graphpad.com is the one I'm using. So there's the link right at the top. It's graphpad.com/quickcalcs, CALCS/linear1. And then I think this one you can just copy and paste the data. So if I copy the age as my x variable, and I want to make sure age is the x variable because age is independent of blood pressure. Age is the independent variable. And then my blood pressure is the y variable. And if I click calculate now, these are websites. These are people trying to make money through ads. You want to probably double check this. So one number I'm going to double check is in Excel. I can get the R value. I can get the correlation coefficient. I can just type in equals correl, open parentheses, and then the order doesn't matter with the correlation coefficient. So you could have done it the opposite way. So 0.09, that's a pretty low R value. And that's that horizontalish line that we saw. Let's see if they got the same R value just to test. That's R squared. It's not quite the same. That's R squared, so we can square root the value here to compare it, see if they were getting the right R value. That's the same thing we got. So looks like this calculator is good. Is the slope statistically significantly non-zero? That's the big thing we want to look for. And there's the p-value for that question. Now notice they said non-zero. That means left or right. This p-value is 0.7594 for both tails. If you're conducting a one-tail test, meaning you're trying to test whether there is a positive correlation, you'd want to take that p-value and divide it by 2. Oops, well, you get the idea. Take that p-value, divide it by 2 in your calculator. I think that's it. That's the big thing we need. The other way of making that conclusion is look at their confidence interval for the slope. They said the slope is somewhere between negative 0.38 and 0.5. So 0 is a significant possibility here. Could have a slope of 0. And if you have a slope of 0, that means the increase in one variable is causing no increase or decrease in the other variable. So all signs are pointing to no statistically significant correlation. If you have two positive numbers here, then it looks like your correlation is positive. It means the increase in one variable is causing an increase in the other variable. If both these numbers are negative, that means you have a negative correlation. That means the increase in one variable causes a decrease in the other variable. Okay? But then the other place to look is the p-value. Whoops, p-value. That's a large p-value. And if you've seen my other videos, a p-value tells you roughly the probability that the null hypothesis is true given this data. Okay, so that's a pretty high probability that the null hypothesis is true. So there's a pretty high probability that nothing's going on because the null hypothesis is like the status quo hypothesis. All right, that's a lot of information. I wouldn't blame you if you want to watch it twice, but let me know if you have questions.